Okay, so for this video we're going to talk about distillation, boiling, evaporation. So this is a method of separating two chemicals based on them having different boiling points, okay? So the key thing here is this graph here, right? These things all have different boiling points, and so if we're careful with how much temperature we add to them, we can get them to separate. So to show you kind of what I mean, I'm gonna make a little key here. I'm gonna make blue water molecules, and I'm going to make alcohol red water molecules, okay? So let's say we originally have some, this is a classic distillation example, right? So you might have watched the video with the industry, right? They use this to distill alcohol to make, stronger spirits, but also to make biofuel as well. So we're going to, since we're in a high school class, we're going to refer to this as biofuel. We're going to purify some biofuel. So anyways, what we have then is, in our original beaker, maybe we have a mixture that's like half alcohol and half water, right? And so this isn't very good biofuel because all that water is going to make it not flammable, right? All that water in there is kind of messing up our alcohol. So if we look down here, by the way, this setup, just so you know, is this thing here. I'm going to draw it red. That's our flame. So this is adding heat. You might also have a hot plate. That's another way you could do it. So a couple things here. The water's boiling point is 100. Remember, boiling point means when is it going to turn from liquid to steam, right? Liquid to gas, which means it'll evaporate and kind of leave this tube here, right? So as we are looking around here, we notice that alcohol boils at 78 degrees, and water boils at 100. So if we're careful with our flame, and let's say we get it to like 85 degrees, right, Celsius. So if we get it to 85, well, what's going to happen? Well, our alcohol, that's too hot for it. It's going to want to boil. But our water doesn't really care. It doesn't boil till 100. So what'll happen is our little alcohol molecules will start to boil into a gas and kind of, let me do this one. So our alcohol molecules will kind of boil into a gas, and so they'll kind of want to come up here and come over here, right? And so as they're boiling away, right, what ends up happening is they kind of come down this tube here. So, right, it's boiling away into gas, kind of comes up, gets trapped, and then eventually what happens is all these alcohols kind of end up over here, right? And so our beaker ends up being full, and it's not a perfect system. You'll still probably have some water kind of come up here, and so you'll have some water. But now look at what happened, right? We have, over here, we have a lot more concentrated water and not very much alcohol left in there, right? Because the water didn't want to boil too much. And then over here, right, notice that it's much more concentrated in alcohol. Right? We have 3 alcohols for every 1 water. So now it's 75% alcohol. This is much more concentrated, and this could be used as a good biofuel. So that's how we can separate liquids based on their boiling points, right? So this is called distillation. So you boil it at the right temperature, under this boiling point, but over this boiling point, and then only this one will go away, right? For the most part. So that's one way to distill things. Another way, and this one's much easier, is look at these solids that we have here. Look at salt and calcium chloride and wax, right? Look at their boiling points, right? I'm going to look at CaCl2. So I put some CaCl2 into a flask, and look at its boiling point, 1,940. This stuff is not going to boil. And so what that means is, if I have dissolved this into some water, and that's going to be this one here, so if I have a solution where I've dissolved it into some water, right? So they're using salt, but I'm going to talk about CaCl2, which is the same thing. They're both soluble in water. So now that it's soluble in water, right, if I want to separate these, I could let it evaporate, which is fine, but evaporation takes a long time. So another thing I could do is I could add some heat to it, and I can boil it. And I don't have to be careful with the temperature here too much, because water is going to boil at 100. Remember, these salts and CaCl2 don't boil until 1,000-something degrees. Our hot plate doesn't go up this high, so this cannot boil in our classroom. Now, what that means is all of the water is going to leave and go off into, wherever, into the rest of the class, and what's going to be left is a pile of solid salt or CaCl2 or baking soda, whatever your mixture might end up being. And so there'll be this powder left at the back, and then we can collect this powder and weigh it and see how much we got. Now, There are a couple things to be careful of. One, if we go here to this camera, let's go to the camera, hold on. So if we look at this camera, right, so I have my flask. So notice I'm using a flask, right? You wouldn't want to use a beaker because as that steam's coming out the top, right, this flask kind of helps keep it in there. If you use a beaker, it'll splatter out the side too much, right? And then I've got this at a pretty good temperature, and you can use your Bunsen burners as well, that's fine. But whatever you use, you want it to be boiling because that means it's really evaporating. So you can see it boiling in there. This is actually boiling a little bit slow, right? Right, and knock on wood, I guess I should have, now that I said that, I got all embarrassed and started boiling real good. This is perfectly fine, right? This isn't hurting anybody, but we do want to wear our safety goggles here. If it boils too fast and you're noticing water splat out the top, or once it starts to solidify, if you start seeing the solid crack and pop out the top, there's two things we want to be careful of, two important things. One is that could hurt us. So we want to be wearing safety goggles, and we don't want to put our face too close to this. And secondly, and more importantly, if things are popping out the top, we're going to have a bad percent yield, and our lab is not going to be as good as we want it to be. So make sure that you're boiling it pretty good so that it separates, but also don't let it like shoot out the top because you'll ruin your results, right? And that's very important. We want good results in here. So just be careful when you're doing any sort of distillation like this. So you have two options. You need to know how to distill liquids, and you need to know how to distill a solid dissolved in a liquid, right? You don't know which one of these you're going to get yet. So make sure you have good notes on both of these so that you can explain to your group how to do it, okay? And then don't forget, flask means the one with the wide, not very wide tip, right? That's what we want to use. Don't use a beaker for this part. Make sure it's in a flask, okay?